So far, we have talked about compounds like this. NaCl. Okay? Simple, straightforward, two elements. We've got sodium and we've got chlorine, which we changed to chloride. Now, we call this a binary compound because it's got two elements in it. It just has sodium and chloride. But there are, of course, countless possible compounds in the universe. In fact, this is a particularly important compound if you have a heart condition. Sodium, and then NO3. Now, what's different about this one is it has sodium, which we know, but instead of having just two elements in it, it has three. It has nitrogen, and it has three oxygens. So we don't say that it's sodium nitrogen trioxide. Instead, it contains what we call a polyatomic ion. Okay? This right here is what is called a polyatomic ion. And that polyatomic ion is NO3 minus, sometimes called nitrate. So this compound is actually called sodium nitrate. And that's what we're going to talk about today, are these polyatomic compounds that are made up of more than one potential element, or more than one possible element. So polyatomic ions are ions that are made up of more than one element. And there's actually several lists of these elements out there. We're only going to learn a few of them. There are hundreds of possible polyatomic ions, but we're only going to learn a few of them. So in terms of polyatomic ions, okay, sorry, I don't mean to fuzz out on you there. Let's see if it'll go back inside. There we go. Okay. In terms of a polyatomic ion, it's just an ion, so it's charged. That means that it's charged. And it's polyatomic, which means two or more atoms. That are a charged species. So, for example, another possible polyatomic ion that we need to learn is called phosphate. And it is PO4 3-. What that means is I have one phosphorus that is surrounded by 4 oxygens Sorry, I've had a lot of coffee this morning. So we have 4 oxygens. And the whole thing acts like it's one negatively charged thing. that has a -3 charge. Okay? That is called phosphate. That's what a polyatomic ion is. So this is the formula. Formula, there we go. I knew the word for formula. That's what the formula is. This is the name. See, the names on the periodic table for elements we just kind of memorize. And the names for polyatomic ions we just have to kind of memorize. There's a list of them, and I'll give you a chart. Of course, you can Google common polyatomic ions, and tons and tons and tons of lists will pop up. But the best way to learn the common polyatomic ions is to practice, practice. We're not going to get into too much detail, but we're going to do some examples real quick to just kind of help us out a little bit. So, let's say I've got the compound, it's Na2 SO4. Sorry, I don't know why it fuzzes out like that. Come on. Fuzz back for me. Fudge. Oh, there we go. Okay. Get that there. There we go. Get the mouse over there. So, we know when we look at this compound, it looks confusing because there are more than 2 elements. And that's the first question we ask ourselves is this, when I come up with the name for this compound, is it binary? So it's got 1, 2, 3 elements. Since it's not binary, at this point, since it's not binary, it must contain a polyatomic ion. Okay? Now, I will tell you that for our purposes, the polyatomic ion will always be the anion part. So, we take the first part here, okay? This first part will be the cation. That means that everything else is the polyatomic ion. Okay? Now I know, because I've memorized the first 20 elements of the periodic table, as a good chemistry student should, I know that the cation is named sodium. And the cation name always goes first. Now the polyatomic ion in this situation is SO4, 2-. And from the chart of common polyatomic ions that I have given you, that you have looked up, that you have memorized, whatever, I know that it is sulfate. So, to come up with the name for this compound, all I have to do is put these two together and call it sodium sulfate. Okay? Pretty straightforward. Not unlike the naming we've done so far. Okay? Let's go ahead and try another slightly more complex one. Okay? Now I've got iron. I have something in parentheses now. Nitrate. Oh, sorry. Gave it away. Oh, I gave it away. Let's do something else. Let's say I have copper. That was terrible. Just ignore that I did that. Shh. You didn't see that. Copper. Something in parentheses. OH. Close parentheses. And I have two of them. Okay. So as I look at this, this looks particularly confusing because I have the parentheses in it. It can be confusing because I have the parentheses in it, but let's not be intimidated by the parentheses. Okay, let's break it down. First off, our question, is it binary? Since it's not binary, it contains a polyatomic ion. So far, that is not, I do want to clarify, that is not always true in all of chemistry. But for our purposes, right now, if it's not binary, it contains a polyatomic ion. Which means there's the anion, or the cation, which is the first part. There is the other elements, and as I told you earlier, if it's not the cation, okay, if it's not part of the cation, it is part of the polyatomic ion. So that means this OH is a polyatomic ion. Which, based on what we have looked up, memorized, whatever, we have learned from our chart, we have learned that the polyatomic ion name for OH is hydroxide. It's OH minus, and it is called hydroxide. And we know that our cation name here is copper. However, we have there's a problem here. Copper can either be copper plus 1, or it can be copper 2 plus. It can be copper 1 plus or copper 1 plus or copper 2 plus. So meaning it's a type 2 metal. And that's something you have to recall, which shortcut to figure that out is that copper is a transition metal. So transition metals are a hint. If it's a transition metal, or a metal you've never heard of, you should probably check to see if it's a type 2 metal. Okay, so we have to work backwards to see which it is. And that brings us to looking at what the charge on hydroxide is. Now, we go to the formula, and we see that there are two hydroxides. Okay. So I'm going to use this blank space over here, so bear with me. I've got one copper, which has an unknown charge. I have two hydroxides. And I know from my polyatomic ion memorization, my chart, however I learned it, that it has a -1 charge. So this plus 2 minus has to equal 0 for net charge of 0 in an ionic compound. Because remember that positive charges and negative charges have to add up to 0 in an ionic compound. So this has to be plus 2. So that means I have to have used copper 2 plus. So it's copper 2. And I use the Roman numeral to show that it's copper 2. And to finalize, I know I've got everything all over the place here. So to put it all together, I have my compound with a polyatomic ion called copper 2 hydroxide. Okay, and that's my final answer there. So that's how we name compounds with polyatomic ion. Like I said, it's pretty straightforward. It is just a matter of practice. Okay. Okay, something I've got here for you is a nice little flowchart that I made, and I'm going to post it on our Echo page, but I just wanted to kind of show it to you to kind of help give you a walkthrough. So when you're naming a compound, when you see a formula, the first thing you should ask yourself is it binary? Okay, so you're going to ask yourself yes or no. Is it binary? If the answer is no, then you're going to ask yourself if a polyatomic ion is present. Okay? So, and the way you know if a polyatomic ion is present is whether or not, give me a second to slide some things here. There we go. Oh my gosh, the focus is terrible. Sorry. The way you're going to know if a polyatomic ion is present if it's one of the polyatomic ions you recognize from having memorized it. Okay? And this is another yes-no question. Is there a polyatomic ion present? And it's a yes-no question. If the answer is no, there's not a polyatomic ion that you recognize, then don't worry about naming that compound. I'm not going to ask you to name something we don't know how to name. If there is a polyatomic ion, you name that similar to the binary ionic compounds that we have named so far. So the rules we're getting ready to go over, you name normally. Okay, so let's go back to the binary compounds. So if the answer is yes to the binary compound, okay? Whoa. If the answer is a binary compound, you ask yourself, is a metal present? This is a yes/no question. If the answer is no, you use the type 3 prefixes, the mono, di, tri, tetra, so on and forth, so on and whatnot. If it's yes, you ask yourself another question. Okay, so if there's a metal present, can that metal form more than one possible charge? Like in the last example we had for naming polyatomic compounds, is it a transition metal, that kind of thing. Can it be like copper 1 or copper 2, iron 2 or iron 3? Can it be tin 2 or tin 4? Okay, or is it like sodium and it can only be sodium 1, or aluminum and it can only be aluminum 3? Okay, so you ask yourself, can it form more than one possible charge? And that's a yes/no question. If the answer is yes, then working backwards, you determine what the charge is on the cation, the metal, and you include the Roman numeral that indicates the charge. Then, to that cation name with the Roman numeral, you include the anion name and the ending with "ide." So, like copper 2 chloride, or tin 4 oxide, etc. If the answer to the possible charge question is no, sorry, can't see that very well, then you name the cation using the element name without a Roman numeral, and then the anion name with the "ide" ending. So this is our really just quick flow chart to kind of help us out when we get lost and kind of confused naming things. So like I said, I will post that on our class site and make that available for you, and hopefully that will help. And as always, if you have any questions, please feel free to let me know.